Hello and welcome to another one of our videos, and today we are going to provide the training for our Sanatron internal pressurization bubble leak tester. Alright, really quick about us. We are Sanatron and we are an engineering excellence company located in Salt Lake City, Utah. We've been in business since 2008 and we are experts in vacuum science and technology, custom fabrication, and robustly designed and quality engineered systems. And we develop, design, and manufacture custom vacuum systems and instrumentation. And we also make internal pressurization leak testing systems. And everything we make is envisioned, designed, and made in the USA. And before I forget, please like this video and subscribe to our channel, of course. Okay, so the objectives of our presentation today are: we will introduce the concept of internal pressurization bubble leak testing. We will also give you guys a notice. We will provide some principles of bubble leak testing, what a bubble leak test is, how to care for your bubble leak tester. We will explain some of the vital components of the bubble leak tester and how to correctly perform a bubble leak test, and provide some additional information that can and are and will be helpful to you. On behalf of Team Sanatron, thank you. We have specifically designed our bubble leak tester to perform package integrity testing or specimen leak integrity testing. And it also conforms to the ASTM procedure ASTM F2096. Alright, so we have to give this notice, and let's get started to it. So please follow this training presentation because it will ensure effective and efficient operation, prolong the life and quality of this equipment, and maintain a safe and secure work environment. Please do not misuse our systems. Also, please do not make any unapproved modifications or changes, and do not pressurize or do not apply any force or any pressure or any stress to our acrylic chamber. And also, finally, the legal notice is that everything that we present is presented in good faith and to the best of our knowledge, and all information presented in this video and also in this training is not legally binding. Let's talk about bubble leak testing. Bubble leak testing is a visual seal and package integrity testing method. The defects are visually detected through the emissions of bubbles, and these emissions of bubbles are detected and also located while the specimen is submersed underwater. And the bubble leak test consists of two critical steps. First one is the generation of a pressure differential, and second one is the visual inspection or visual detection of bubbles. And with regards to the internal pressurization test, since the pressure inside the specimen is the same as the ambient pressure in most cases, a way to actually bring higher pressure into your specimen is actually done through a pressure probe, where the pressure probe is inserted into the test specimen. And generally speaking, the higher the pressure, the higher detectability of the leaks, so you'll be able to detect smaller leaks. But on the other hand, a higher pressure can also inadvertently damage your specimen, your good specimen. So there is a trade-off here, and there is a balancing act, and that's something that you will have to determine internally while you're doing your tests. So the advantages of the bubble leak testing are, first of all, they're cost-effective. It's a cost-effective seal integrity test method. It's also a simple and easy leak test. It's very practical when you're testing pouches and packages. You can also visually detect and locate package leaks, and it's a quick sample prep. To prep your samples, you don't require any jigs or any other special equipment. It's everything is right there. And also, it's a versatile testing method, meaning that you can test different pouch sizes, different pouch shapes or containers, you name it. As long as you have a way to bring in pressure internally into your test specimen, you will be able to perform an internal pressurization bubble leak test. The disadvantages are that it is a destructive package test, meaning that the packages will be destructed and you will not be able to put them back online and also sell them to your customers, because you will first of all, have punctured your test specimen. However, that is not always the case, because sometimes you can perform an internal pressurization test and then you can close your access port, and then essentially this, if the test is a pass, the specimen is a pass and it can be sent to a customer. And sometimes that's a way to go, where some of our clients, they have performed 100% inspection on every single item that they send out, and it is not a destructive test. But however, for example, pouches or something where the film is damaged, yeah, it is a destructive package test. And the second disadvantage is that it is a subjective leak detection method, meaning that it is operator dependent, and sometimes the leak detection is subjective. You will have to see it, and it will vary from operator to operator. But if you have a good training procedures and good testing protocol, this subjective part of this test can be mitigated and minimized. And then the third disadvantage is that sample preparation and handling. Sometimes this preparation and handling can be a pain in the butt, because sometimes it requires extra steps to handle and decontaminate your specimen, and that can be a disadvantage. And finally, bubble emission test procedures are specimen dependent. So it depends what type of a specimen you have. Sometimes you can have small pouches which disqualify them for internal pressurization testing. Sometimes your film can be brittle and you may not be able to perform internal pressurization testing, because as soon as you insert your probe, you will damage the film, and then you will create a stress crack and completely damage the the test specimen. So it is specimen dependent as well as operator dependent. So again, those are the disadvantages. So let's talk about how you should care for your internal pressurization bubble leak tester. So first of all, safety warning: it is heavy. So make sure that you handle it properly and that you do not misuse it, and make sure that you do not lift anything that you cannot lift, because there is a risk of injury. And also, the acrylic tank is fragile, so please, your portable system should be transported with care. And thirdly, it is sensitive to a thermal shock, meaning that as you're filling up your acrylic tank, the thermal expansion properties of acrylic are slightly different than the thermal expansion properties of water, which could create some stress. And also create some thermal shock, cracking. The way to mitigate that is to go ahead and, when you're filling up your tank, do not fill it up with extremely hot or cold water. Fill it up with lukewarm or room temperature water, and you should be okay. Even cold water from the faucet should be okay, as long as it's not extremely cold or extremely hot. And then also, do not apply or expose solvents, paint thinners, alcohols, or anything of that nature to the acrylic, because they will craze and blemish the acrylic, and attack the acrylic. So the best way to clean your internal pressurization bubble leak tester is to use a plastic cleaner, Novus #1 plastic cleaner. You can get that from us, or you can also find it on Amazon or at your local plastic store. And you essentially just apply it, you spray it, or you put some cloth, put some of it on the cloth and then wipe it off. Or you can also use soap water. Make sure it's not antibacterial soap, because those have alcohol on them. So make sure that it's just a regular soap with some water, and you can also clean acrylic that way as well. All right, let's explain some of the components of the internal pressurization tank. We'll start with the sliding lid lock. Essentially what it does, you slide it over and you lock this lid into place, and this perforated lid is there to essentially help keep your sample submersed underwater, especially the ones that are, you know, inflated with air, and they will, you know, float upwards. So this lid will actually keep it submersed. This lid also has magnetic lid latches that will help you when you open the lid. It help you keep the lid open at a 90 degrees angle, and that 90-degree angle, you know, helps you for hands-free operation. Every lid has either 2 or 3 hinges. There's also an overflow protection tank, which will keep any excess water that goes beyond a certain level. It will just overflow. Any excess water will overflow and also, you know, get drained through the overflow drain. And then finally, you have a drain valve that essentially needs to be closed if you need to, you know, fill your tank with water. Um, this whole assembly sits on a aluminum frame structure, and this frame structure can either come on lockable swivel casters or it can come on adjustable feet. So in this particular image, we have lockable swivel casters. All right, and so the explanation of the you know, internal pressurization setup is that you have a pressure pedal. You essentially, it's a foot operated pressure pedal. As you step on it, you open the pressure line and you initiate this test probe with pressure. So as soon as you insert your test probe, you push this pedal and then pressure will start being initiated into your test specimen. Then of course this whole system is pressure regulated from 0 to 15. You can potentially go higher. This particular one is 0 to 15. And then finally, this system also has a magnehelic gauge, meaning that it detects a pressure difference between the samples. So there's 2 lines here. One is pressure in and the other one is pressure differential, meaning that if you have your probe inserted into your specimen and your pedal is pressed and you are seeing a pressure differential, there's 2 reasons for that. First of all, your sample is inflating, or second of all, there is a leak because there is a pressure drop, since the pressure coming in is not the same as the pressure inside the pouch. Now keep in mind that this feedback system is not necessary. You can directly connect this pressure probe. It could only be a single tube and it can be connected to your valve. It's just another extra feature that you do have with this system, and it's also nice to actually have a you know, visual indicator or a instrument that indicates a pressure difference. But keep in mind that a visual inspection of bubbles or leaks that you will detect inside the tank is much more sensitive than the magnehelic gauge can detect. Alright, so we will do a video on how to correctly perform the internal pressurization test. Okay, here we go. So we have our test specimen, which is this green bag right here, and the first thing we're going to do is we're going to cut the septum tape right here. And then what we'll do is we will punch a hole inside the septum tape. Then what we do after that is we will remove the backing tape, because the septum tape is essentially has an adhesive side on it. And let me show you what we're going to do here. We will remove right there. We remove the backing, and then we apply the septum tape onto our test specimen right there, and then make sure that it is properly applied to it. And then we will go ahead and we will puncture a hole through here, and we'll make sure that we puncture it through the punched hole, and we puncture a hole. Now the reason we have the septum tape is because we will insert the probe now, and the septum tape creates a good seal between the pouch and the probe. And now the probe is in, and then with your foot, as you can see on that pedal, press the pedal and let your test specimen be inflated with air. And you will notice that the magnehelic gauge is going to drop, And the reason that it will drop is because that indicates that your package is fully inflated. Now place them into your water tank. Of course, close the lid and then lock the sliding locks. And then you will hold the foot pedal, and you will do is you will look for bubbles. And you can kind of nicely see that the probe is in there, and you'll look for bubbles, and this is actually a good specimen. So this is a good test. The test here is a pass. And this is essentially how you perform a visual test. You look from the top, you also look from the sides, and then what you will do is this test is a pass, and you unlock the sliding locks, and what you do is you open the lid. And this is what we talked about, the magnetic latches right there. But what we'll do is we will create a leak. And this is an acupuncture needle, and this needle is about 8/1000 of an inch in diameter. So this means is that we have an 8/1000 of an inch diameter hole inside that package. And now you can see that there's a continuous stream of bubbles coming out of the package and out of the hole where we poked it, or where we punched the hole with that acupuncture needle. Now what you can do is you can rotate your test specimen, and to better kind of see your bubbles, or to let the bubbles escape. This is essentially what an internal pressurization bubble leak test is. You essentially apply the pressure through the pressure probe, and the air is going to be escaping out of this pouch through the leak path. Okay, so we're going to open the lid, and what we'll do is we are going to look at our package, and you'll notice that on our magnehelic gauge there is a little bit of pressure difference, and I'm not sure if you can see it, but let's see if we remove it, you see, and then we can let our package deflate, and you're gonna see that there is no pressure difference. But then if you insert your test probe, and then you press down the foot pedal, and then you will notice that the pressure difference is about 20 inches of water as the package is deflating. And that's because the pressure going in is not the same as the pressure being detected. Now, as your package is fully inflated, you will still see a little bit of pressure difference, and that's because you do have a leak. So in a way, you could theoretically detect a leak simply through a pressure difference in your test specimen. However, you will not be able to locate the leak. The leak location happens while the specimen is underwater. So here we go again. We're going to kind of take a look at it from a different angle. And as you can see, there's a continuous stream of bubbles that's coming out, and it's kind of collecting here onto this perforated lid here, but it essentially just goes up towards the top. And then you have this pressure probe. You can kind of see this is our setup, and what we'll do is we'll puncture some more holes right there. Now you can see some more bubbles coming out. We'll puncture it right there and here, and what we'll do, we'll try to come from the bottom too. As you can see, you can kind of see these leaks coming out, these continuous stream of bubbles. And let's see, here we go. We're going to come in and we will puncture from the bottom. We'll bring our hand in, and here we go. There we go. One more. Here we go. See that one? That's so cool. Well, that is it. That is our internal pressurization test, and you notice that now the pressure differential is a little bit higher, and that of course is because there's more leakage happening. Alright guys, this is it. So thank you for watching. Please like and subscribe, and if you have any further questions, feel free to contact us. The contact info is of course shown when you visit our website or here on our YouTube channel. So feel free to call, feel free to email us. Let us know if you have any questions, concerns. Post them either in the comments below or email us or call us. Thank you so much for watching, and thank you so much for being our customers, and you guys have a wonderful day.